Welcome to the rate of decomposition of calcium carbonate lab. For this lab, you're going to be reacting hydrochloric acid with calcium carbonate, which is more commonly known as marble. For the first step, measure out about a half a gram of marble and use the solid marble chips, not the powder. Then come over to the acid station and make sure if there are multiple acids put out that you're going to the 6 molar hydrochloric and retrieve 10.00 milliliters of the 6 molar hydrochloric. Again, this is for the introductory activity day 1. I recommend using the Barral pipettes I have out to ensure that your meniscus for your acid is sitting right on the 10, so you can get 10.00. Let me introduce you to your reaction vessel. We've got our Erlenmeyer flask where the reaction will take place, and we have a syringe. And so this is a closed system, and as you produce carbon dioxide gas, we will capture and measure that gas in our syringe. Now, you'll be graphing the volume of gas made versus time. And I recommend having a spreadsheet open so you can enter those values and then graph them in real time. Here's an example of the spreadsheet that would be useful for the introductory activity. Notice that my time is in minutes. You're going to be collecting carbon dioxide for 10 minutes. And you also want to have recorded the mass of your calcium carbonate you started with. That should be somewhere around a half a gram to 3 decimal places. And you've got your room temperature and your room air pressure, because you're going to have to do some ideal gas law calculations for the introductory activity to say how much carbon dioxide could you have made given which one of your reactants is limiting. Before you add your reactants, make sure that your clamp on your syringe is nice and loose. And when you move that up, it should slide easily. And you can remove your Erlenmeyer from your stopper. Push your plunger all the way down and make sure the piston inside is completely depressed. And that will assure that you start at a 0 volume. And once you're ready, add your marble chip, and you're going to add your acid, and as quickly as possible, close that system. Close it nice and tightly. And the reason that I have the clamp on the syringe is so that you can stir. You want to stir pretty constantly, but you want to also keep an eye on that stopper and make sure that the stopper is tightly seated into the Erlenmeyer flask. Now, of course, you started your timer right when the reaction began. And you're stirring, and at 1 minute, you're going to measure your carbon dioxide volume. I'm approaching my 1 minute first volume measurement, and there's a technique here. Now I'm at 1 minute, where you'll take your plunger, push it down, make sure that the plunger is moving, and then wherever it stops at, it looks like I'm at 42 milliliters. And that's only 2 sig figs because we don't have much precision with these syringes. All right, I've just hit the 2-minute mark. So again, you want to, before you take each measurement, push the plunger down a little bit because the plungers tend to get stuck. And then take your second measurement at 2 minutes. It would be really smart to push this plunger before your 2 minutes, maybe 10 seconds before your minute mark for each of the minutes up to 10 minutes. And so that you can get a more accurate measurement. I want to emphasize the importance that as the reaction goes on, we would expect it to slow down as we run out of reactants. And so to keep the pace of the reaction consistent throughout, continue to do what I'm doing. Continue stirring or agitating. Now, for me, at about the 6-minute mark, I notice I'm no longer making any gas in my reaction vessel. So at that point, you can make a call. If you shut it down at this point, then you risk maybe not completing the reaction. But what's most important when comparing the effects of reaction rates, the effects on reaction rates of changing temperature or concentration, like this lab is asking you to do, initial rates are the most important thing. So we have a really strong initial rate for the first 6 minutes, and then it looks like our reaction stalls out completely. And at this point, if you want to call it, instead of sitting around and watching it for another 3 minutes, then, because I'm at 7 minutes now, then go ahead and stop. At the end of the introductory activity, I've got my graph, I've got my labeled axes. I assume that since the reaction stopped at about 7 minutes, that my volume stayed the same. And so now you can proceed to the questions for the introductory activity and planning your lab for day 2. Also feel free to do a second trial. You're going to have plenty of time on day 1 to plan your inquiry activity for day 2 and to do a couple trials for the warm-up activity. And if you do a couple trials, or even if you just do one, at the very end, move your syringe up, and I want you to take this and clean it out in the sink. We've just got calcium and chlorine and water in here. So the products are very benign, and we can just clean this out in the sink. Make sure this is nice and clean before you do a second trial or before you leave the lab for second period or for the next period. The very last thing I want to help you with is how to plan day 2, which is your inquiry lab activity. I should be telling you very little about how to plan day 2, but I've made this spreadsheet for you, or a data table, so that you can think about it. Now, I want to know what you think and what you've measured about how molarity of your reactant acid affects the production of calcium carbonate. I want to know how temperature affects it. What would happen if you cooled it down? Would it speed it up or slow it down? If you heated it up, would it speed it up or slow it down? I also want to know what would happen if you changed the surface area. Does making calcium carbonate a powder increase the surface area or decrease it? And so you do not have to do all of this. But what I want you to do is have all of this data. I want you to have rates for all of this. So that means you're going to have to work together as a class to divide and conquer and include all of this information in your final lab submission. All right, that's it. Take a picture of this or write it down, and good luck.